Damn it, Rodriguez, stop getting in my way. It's already 2 a.m. and we have to finish 100 of these before dawn.
Good thing we only have 19 more to go.
Sorry, Mick. I just... Shanghai.
At ease, Colonel Mortensen just informed me that we have a new mission, and as a result, we have to change what we're making. As of right now, we are no longer making missiles. We are switching to soaring cellulose composite loitering munitions that need at least 500 nautical mile range. Sergeant Smith, how long until we can switch over production?
Once I have design parameters. 3 days, sir.
Sir, our missiles just aren't proving effective against those hidden targets. We just can't meet our mission objective. What we need, in my opinion, and fast, are soaring cellulose composite loitering munitions that can fly 500 nautical miles or more and pinpoint targets. Our supply chain is non-existent, so we'd need to make them ourselves.
Major, how long will it take to shift over our on-base production?
Normally about 1 week. But we have this new R&D system from DARPA called Autonocad, which may be able to help us do it in a matter of hours.
Okay, John, let's do it. Diaz, tell your team to use Autonocad and start making loitering munitions immediately.
Sergeant Smith, how long until we can switch over production?
Once I have design parameters. 5 minutes, sir. Good. Excellent.
Agile manufacturing demands eliminating bottlenecks between requirements, design, and production. Today, we introduce Autonocad, an AI pipeline that converts requirements, images, and sketches directly into precision CAD models and manufacturing instructions in under 5 minutes, bypassing low-rate initial production, or LRIP, entirely. Current manufacturing requires months of iterative prototyping and LRIP validation. With Autonocad, we collapse this process by combining breakthroughs in visual language models, spatial reasoning large language models, and real-time manufacturability optimization, which is a novel contribution. This enables direct-to-full-scale production of mission-critical components with guaranteed geometric and available feedstock material and manufacturing equipment compliance. Autonocad is a 3-stage process. Stage 1 is semantic parsing, where Autonocad extracts discrete geometric primitives and material constraints from images and sketches, and mission requirements are taken into account. Stage 1 outputs a labeled CAD command structure with semantic annotations. Stage 2 is spatial assembly, where an Autonocad spatial reasoning engine resolves geometry 3D tolerance stackups and computes dynamic load paths. Stage 3 is manufacturing optimization, where a physics-informed neural solver generates toolpaths minimizing subtractive material waste, additive layering strategies preventing warping, and in situ quality control markers for automated inspection.